All right, thanks so much everyone for joining us this evening for our Septic Sense Workshop. I'm Danielle Enns, the Land Care Coordinator with Clearwater County, and presenting for us tonight we have Rick Baxter, board member with the Alberta Onsite Wastewater Management Association. Rick is heavily involved with code development and training for the private sewage industry. And as a safety codes officer, Rick is well versed in all the ins and outs of septic systems. So just a couple things. We'll keep everyone's cameras off to limit distractions. Looks like everyone's is off anyway. And then just a reminder from the email that you were sent earlier, the workshop will be recorded and uploaded to Clearwater County's YouTube channel. And if there are any questions throughout, we just ask that you wait until the breaks. The first one should be around 6:45. So feel free to type your questions into the chat box at the top there, or you can turn your mic on at that time. And I just want to mention also for those who registered, if you weren't able to pick up a septic package from our office prior to the workshop, they will be at our Ag Services office for you to pick up at your convenience this week or the next. So with that, I'll hand things over to Rick.
Thank you very much. All right. So my name is Rick Baxter. I'll be presenting Septic Sense for you tonight. I've done quite a few of these Septic Sense programs, preferably in person. However, you know, with things being the way that they are these days, in person is not really an option for at least the next while here. So we have shortened up the program somewhat in order to be able to do this as a webinar. This is presented by Clearwater County as well as the Alberta Onsite Wastewater Management Association. The association provides all the training for certified contractors in the province, is heavily involved in the industry in helping to write the code or the standard of practice, investigating when there's issues, when things go sideways, advocating for water reuse and the like. So our outline for this is an introduction to septic. So what is a septic system? What are the goals of sewage treatment? How do you find your septic system? How a septic system works? We'll talk about initial treatment components, so things like septic tanks and sewage treatment plants. And then we'll talk about final treatment components as well, things like septic fields, septic mounds. We'll touch on at-grades a little bit. We are going to talk about regulations. Of course, you know, with anything that might impact the environment or other people, there will be regulations involved. We'll talk a little bit about design and installation, give you a kind of a 30,000-foot view of what it takes to actually design a septic system and then for the install and whatnot. We'll dive more into appropriate use of your septic system, the do's, the don'ts, the frequently asked questions, and that sort of thing. We will discuss how to maintain your septic system and a little bit on troubleshooting as well for when things are not working quite right for you. So what is a septic system? A private septic system is for the collection and treatment of wastewater generated by a home or business on a rural property that's not connected to municipal services. This typically includes a soil-based treatment component for when we dispose of it on site. So again, the septic mound, septic fields, and that sort of thing. It could also be just as simple as a septic holding tank where everything just goes into the tank and you have the vac truck come out. As well, privies or outhouses do fall under the private septic system and under the standard of practice. Sources of wastewater are human and animal wastes, obviously, and household wastewater. We don't typically put groundwater sumps into our wastewater streams just because it does dilute things quite a bit. So we try to avoid having that in there. And you're not going to see too much industrial waste going into a private sewage system. And just so we're all aware, questions when we do have a break, about the middle of this. I'll take some questions there. Just type them into the chat as well. I'll stick around afterwards and answer any questions at the end of the program as well. That way everybody gets the information they're looking for. So what are the goals of sewage treatment? The goal of a septic system is to treat and disperse sewage and effluent on site so that the sewage or effluent does not present a risk to public health and does not cause degradation of the environment. So we produce the sewage on our property and we're treating the sewage on our property. We can't just pump it across the fence onto the neighboring crop and that sort of thing. It has to be on our own property. Did you know wastewater is a mixture of black water and gray water? Both must be treated by your septic system. So there's a lot of misunderstanding about private sewage with gray water. A lot of people think that the water coming out of your washing machine or out of your kitchen sink or even your bathroom sinks can just go out onto the ground. That is not actually fact. We can't dispose of gray water differently. So there's a lot of people that will consider composting toilets, for instance. So they use the composting toilet to, use as a toilet, and then they've got their gray water, and they think that just pumping the gray water out onto the surface is perfectly acceptable. Just let it run out and away you go, and then they're just treating the black water with the composting toilet. That is not actually the case. If you do have a composting toilet that is desiccating your black water, the soil that you're creating from there does need to go into a septic system or to a sewage treatment plant or to the landfill if they'll accept it. I would recommend not doing that, but actually have your black water go in with the gray water into your sewage treatment. That way the bacteria is able to do its job properly. As much as we'd like to think that gray water is a lot cleaner than toilet water, there is quite a bit of bacteria that ends up in there, and we do have to deal with it appropriately. 1 in 5 Albertans have a septic system. We treat over 30 million gallons of water or septage every single day with septic systems. Basically, if you're not connected to a pipe that's running to a municipal system, you will have some sort of private sewage system. So one of the common questions that we get is, how do you find your septic system? You just bought a property, you're going out there, you're having a look around, you're trying to figure out where everything's at. So you can look for some as-built drawings, okay? Or possibly if you had a home inspection for real estate, they might have an idea where your septic system is. Typically, the home inspectors for real estate transactions do not look at the sewage systems, so they may or may not be able to point that out to you. As-built drawings for the home, that might be in a permit package. You might be able to get a hold of either the municipality or the Alberta Safety Codes Authority, where they can find a copy of the permit for you, get you that package, and then there will be a drawing in there showing where everything is, assuming the system was put in as it was intended. You can look in your yard for lids, manhole covers, inspection covers, pipes coming up, mystery caps. In a lot of the older farmyards, you might see that there's a straw bale or two sitting out in the middle of the yard, and there's a piece of plywood underneath that. That is likely going to be where your septic system is. The way to tell is to pull those bales off and then open up that plywood. Now, if you are going to do that, do not step on that plywood, please, because odds are you don't have a concrete lid underneath it, or if you do, it might be in really bad shape. You don't want to walk over that plywood because if it's rotten, you're going to go through it. And if there's no lid, you're going to go pretty deep. Okay. You can contact a septic maintenance provider or a pumper to help you locate where your tanks and your septic system could be. They might be able to determine where it is just by looking at the site. They might have to do a little bit of probing and that sort of thing in order to find it if the system's been in place for quite a few years. And again, you can get a copy of the septic permit from your municipality or permitting agency. However, that's only good for systems that are about the last 12 to 15 years old. Older than that, it's really hit or miss because there was a lot of systems put in through the years that did not have permits and didn't, frankly, have the oversight that should have been there. So how does a septic system work? Just going to get a laser pointer. All right. So we've got our house here in the foreground, or in the background, sorry. We've got a well, and you can see that the well is drawing from the well point from the water table. Now from the house, we're coming through, we drain everything down into the septic tank, and then these lines right here, those are called laterals. So this would be a septic treatment field or drain field. These are trenches that are in the ground. They may or may not have pipe inside of them. They may or may not have gravel in them. They may or may not have chambers, which we'll talk about a few of those other options as we go. So the general idea of how this system works is everything that you flush from this house, black water and gray water, goes in the septic tank. When it gets in the septic tank, if it's sized correctly, it is treated in that tank for at least 2 days. And then the effluent comes out. So it goes into sewage, comes out as effluent. The effluent goes out and it goes into the laterals. Now you can see here that we've got evaporation. So it used to be that the understanding was that the vast majority of the effluent would be picked up by the grass and we'd have evaporation. But it turns out we've only got about 3 to 5% of the sewage or effluent that we're putting into the field is actually going up as evaporation. The vast majority of it works its way through the soil until it gets down to a water table. Okay, and you can see the arrows are coming down, it goes into the water table, and there is a potential for it to come right back over to the well and come right back up. Now, seems a little gross, but as long as we've got a properly designed system, the tank's big enough, we have enough laterals in the fields that we're not adding a bunch of effluent in one small spot or point loading it. As long as we have a prescribed amount of soil that can accept the effluent at the rate we're putting it into below this drain field before we hit that water table, then we get effective treatment, and that water, after it's gone through this prescribed amount of soil, is deemed potable again, where you can actually bring it up and you can reuse that water for showering and cooking and cleaning and everything else that we use the water for. If, however, we don't design the system correctly, maybe the tank's too small so we're not getting decent treatment in there, maybe the field is not installed correctly, maybe it's too deep, maybe it's not big enough, whatever the case might be, maybe our water table is too close to the bottom of the trenches, now we've got improperly or partially treated effluent that's working its way back into the water table until it finds a way up and out. Okay, now it might be going up into somebody's well miles away. It could be breaking out, going into a river, stream, going into a lake, whatever the case might be. If we don't have proper treatment of that sewage, we are causing problems for the environment. So with a septic field, which just has a normal septic tank, we actually need to have 5 feet of soil. So from the bottom of the trench to that water table, we need to have 5 feet. If we've got anything shallower than 5 feet, we cannot use just a regular septic tank and we can't use the drain field. Okay, now that's 5 feet from the bottom of the trench, not from the surface. These trenches have a maximum depth of 3 feet. They have to be up near the surface to allow oxygen to get down through the soil to help treat the sewage. So how does your septic tank work? A septic tank provides mechanical separation of sewage. So your fat, oil, and grease, or fog, and lighter inorganics will float to the top of your septic tank in the first chamber, and that forms your scum layer. Then your heavier inorganics are going to settle to the bottom, and they form what's called the sludge layer. The middle, or clear zone, is carried over to the second compartment where everything pumps out from. Septic tank creates what's called a primary strength effluent. So the septic tank itself is an anaerobic environment or non-oxygen bearing environment where the bacteria breaks down your scum, breaks down the sludge layer, and clarifies it to an extent. And then your second chamber of the tank, that's where everything pumps out from. So it cleans it up quite a bit, but it doesn't do the entire job. To do the whole job, we need to have that soil component to it. That way we know that we're getting proper cleaning and we can get that sewage effluent clean. A septic tank is not a holding tank, okay? There's a lot of people that they will buy a large septic tank to use as a holding tank with the intention of at some point maybe installing a soil-based system. Septic tanks are not holding tanks. The septic tank has the pump connection and everything else to it, and they're not intended to use as a holding tank. So here's an example of a septic tank. Okay, we've got the ground level up here. This one has 2 manways into it. Okay, but depending on the type of tank you've got, who manufactured it, when it was manufactured, that sort of thing, you might only have 1 manway that comes over top of this baffle. Okay, now this one is plastic ultra rib. There's others that are fiberglass, other types of plastic, as well as concrete. Okay, now you see this says 4 feet. 4 feet is the shallowest depth that you can go with a septic tank without insulation. Okay, if you had 2 feet here from the top of the tank to the soil, you'd have to insulate the top of the tank as well as any portion of the tank that was shallower than 4 feet. And that's just to keep the frost out of it, to keep the tank nice and toasty warm, so that our anaerobic bacteria that's in there can thrive. We want a lot of bacteria in there because they are destroying this scum layer, right? So your fog, as well as your sludge layer, okay? And you see we've got a clear zone in here. Now it looks nice and blue on the picture, but it's not that clean, okay? Our inlet from the house comes here, and you can see there's a little T here to work as a bit of a baffle. That way we don't stir things up in this tank. We want to get that separation. We have another baffle here that takes water from the clarified or clear zone and brings it over to the pump chamber side. Now you can see we do get a little bit of sludge that will work its way through. We will get a little bit of a scum layer that works its way through there as well, because we're still getting further treatment in here. This section here, we want the sewage to be in there for 2 days. That way it fully separates and the bacteria starts to work away at it. When it comes over to here, now we're dosing out to our soil-based system. Typically, the pump is going to be sitting on a block, so it's above the floor of the septic tank. That way we're not pumping any of this sludge. It also has floats set up onto it where it won't pump all the way down, so the little scum layer that we'll have here will always be there. This clear zone here, it'll go up and down, with pump cycles and that sort of thing. Now, what we don't have shown in this picture, just because we're trying to keep the picture cleaner, you don't see the piping coming from this pump. Typically, the piping is going to come up into this manway. It's going to come across, and you'll have a union here. And then you might have a filter in this spot. Then the piping comes back down and heads out. You could also have a pump screen that just fits right about here. The pump sits inside of it, okay? If you were to watch this system working and the pump kicks on, when the piping comes down here and comes across, there's a little hole that gets drilled into the piping right about here. And that's for a drain back. That way, when we pump these tanks out, when they go out to the soil base, anything that doesn't spill out onto or into the soil is able to drain back into the tank. So if you happen to be looking down there, when you see this happen, you see the water spraying out, it's not because your piping's failing and there's a hole worn into it or anything like that. It's actually a design requirement. Another option we've got is advanced treatment units or sewage treatment plants. Now, you can have primary treated effluent coming from a septic tank, or you can do advanced treatment units such as these ATUs. What they do is they give you a secondary strength effluent. So you get the raw sewage coming into it, and it actually treats it a lot more than a regular septic tank. So what you can think of these as a sewage treatment plant, kind of like what you'd see in town or in the cities, but on a small one house residential lot size. Okay. They don't have the ponds and everything else that you've got in municipalities. This is all just a little plant, and I'll show you some examples of these. If you've got really poor soils on your site, you might consider putting an advanced treatment unit in there. That way you can reduce the size of your septic field. You can reduce the amount of sand you might need for a sand mound. You can also look at doing an at-grade if you've got a lot of trees on your site. I know a lot of areas around Clearwater, you have a lot of trees in there. You might want to save those as much as you can. So you'd be looking at an at-grade with an advanced treatment unit. And we'll talk a bit more about those as we go. So we've got these advanced treatment units take that raw sewage and they treat it a lot more, but there is more bells and whistles to it. So this one is an example of an attached growth system. So here's our inlet pipe with the sewage coming in. It goes into a pre-treatment compartment. Now, depending on the advanced treatment system or sewage treatment plant that you have, some of them will actually have another tank right in the front here that the sewage goes into first to allow things to settle out before it goes into here. The reason for that is a lot of people flush things that they shouldn't, that do not belong in a sewage system, period, whether it's a septic tank or an advanced treatment unit. There's a lot of things that just don't belong in your system, and we'll talk about those a little bit later on. So we have that trash tank to get rid of those first before it comes in the air. So this one's got the attached growth media here. So what that is our bacteria lives on there. So the sewage comes in, goes through this media where the bacteria is able to do its job. But you can see they've got an aerator on this. So with the septic tank being an anaerobic environment with anaerobic bacteria, the sewage treatment plant is an aerobic treatment plant. It adds oxygen and it's different bacteria that's working to break down our sewage with it. The oxygen-loving bacteria, the aerobic bacteria, actually does quite a bit better job. It's a lot hungrier and does its job more effectively. So you can see this is our treatment compartment. Then you have a little bit of a settling compartment with this one, and then the discharge line coming out of that going to your soil-based system. Another type of system is a textile package plant. So this one's got quite a few other pieces to it. You can see the inside of the box number 4 here. That's your filter cloth. Okay. So your sewage comes in from the front here, comes into your system, settles out in this tank, gets pumped up through this cloth, works its way down, comes in. You can see that you've got aeration here. We've got a filter in this spot as well, and then it eventually goes to your soil-based system. Okay, it has web-based monitoring typically. You've got a processing tank, you've got a pumping package, there's a filter cloth, and then there's a recirculating splitter valve. So it will push it out to the field, but it's also going to push some of it back into the tank and just keep cycling and cycling and cycling in order to clean that effluent. Another option is a mechanical gear-driven plant. Okay, you can see we've got motors and everything else in here to turn stuff around and mix it all up and add your oxygen to it. Any one of those types of systems is an approved system, okay? The packaged sewage treatment plants, they all have to be approved to a standard. There's 3 or 4 different standards that they're able to get those approved to, okay? But you can see they all do basically the same job. So this is before and after treatment in a packaged plant. So you have a sample of dirty water here, okay, and you can see we got a little bit of a scum layer on the top and we got some sludge layer on the bottom and that sort of thing. That's basically what the inside of your septic tank is going to look like. So if you're doing just a regular septic tank and a septic system from there, this is the type of fluid that's going to go out to your soil-based. Whereas if you got a packaged treatment plant, you got a lot cleaner fluid. This is what happens after that plant. So the aerobic bacteria is able to get us to this stage. Anaerobic bacteria here. Aerobic bacteria is able to get it a lot cleaner. And that's why we're able to put the sewage effluent in a lot tighter soils and a lot smaller areas if we put the package treatment plant in there. This is really good example of why we're able to do that. So we get into final treatment components. There's quite a few different final treatment components. This type here, septic field or weeping laterals, dispersal trenches, disposal field, treatment fields, it basically all means the same thing. Okay, this is a septic field. So in the foreground here in this trench, this is where we've got our header. Okay, and then we've got lines called laterals here. We got one here, and there's here, and you can see the different piles of soil there. The main thing to keep in mind with a disposal field or treatment field is these trenches have a maximum depth of 3 feet, like I mentioned before. Reason being is we need the oxygen to get down into where we're applying the sewage effluent. So if we're applying the effluent out of a septic tank, anaerobic, we're pushing it into here. Now the aerobic bacteria takes over and does a lot more cleaning of that sewage effluent. Okay, so we need the oxygen to get in there. We have to keep these trenches from being too deep. Otherwise, the sewage is basically untreated because the aerobic bacteria is not able to do its job. Another thing to keep in mind with sewage treatment field is we've got separation between these laterals. There has to be a minimum of 3 feet of undisturbed soil between the laterals. Reason being is when we apply the sewage effluent into these trenches, it will actually climb up the walls a little bit, just helping to disperse that effluent. If we were to basically dig a shallow swimming pool, so no space in between these, we go down 3 feet and it's just lateral, 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 it's not going to get proper treatment and you're actually just going to end up with one giant mud pie. The sewage effluent is not able to disperse. It just sits there in one big muddy pool. Okay. Now, with this one, they've got chambers, as you can see here. There may or may not be a pipe running down inside of all this as well. If there's a pipe inside there, it's a pressure distribution field, which means there's a pipe with orifices drilled into it every so often, depending on the design, that sprays the sewage effluent inside these chambers. It could also be gravity fed, where we push into the header and then it just spills down into these chambers. Okay. Another option is you don't have the chambers at all. You have what's called pipe and gravel. So you'd have pipe coming along here and then washed gravel over top of all that. And then you don't need to have these chambers. Most people do the chambers these days now, only because washed gravel is really hard to come by and it's getting more and more expensive all the time. So here's a couple of examples here. So here is a house, septic tank, so it's anaerobic. We've got a distribution box right here. They don't all have distribution boxes. Some do, some don't, depending on how the piping is all laid out. Okay, if all the runs are all even, then you don't need a distribution box. If they're uneven runs, then you'd have a distribution box just to kind of help direct the sewage effluent around to where it needs to go. Now you can see that this one only has 2 rows of chambers. It's kind of misleading because you're not going to have 2 short runs typically for any size of house. Okay, the system is going to be bigger than that, but you can see that we've got the trench dug, we got native soil in between. We're not importing soil for this. We're not digging everything out. It is actual trenches coming through. So this one's got the chambers, but here's pipe and rock, like what I was talking about earlier. Okay, so it's washed rock. We've got perforated pipe coming up through the middle of it. We've got a geotextile fabric over top, and then we've got our soil put back into there. And this would be a trench from here all the way down. Again, maximum depth 3 feet from here to here. Okay. The purpose of the geotextile fabric is to keep the silts and clays from filtering down through here and clogging all the pores in this rock. The rock is here to help disperse that effluent and to allow it to adhere to the rocks to allow the oxygen to get around it. Another option is a sewage mound. Okay, there's all kinds of different names that people have used for it, but basically this is a septic mound. Okay, if you have an open discharge on your property where the pipe just comes up out of the ground and sprays the effluent down on the surface, and there's a bit of a hill under that, that is not a septic mound. There's a lot of misunderstanding with that. A septic mound is imported material put on top of the surface. So you see we got our house down here. We've got a regular septic tank. Now, this is typically going to be a regular septic tank, but if you've got really difficult soils, you might even consider putting a sewage treatment plant here. Okay. Now, this is a little bit older slide, but you can see this kind of beige area here. This is washed concrete sand. Okay. It's a very specific grade of sand that needs to be used for this sand mound in order to be able to effectively treat the sewage. If we have too much silt and clay in this sand, what will happen is it will filter down and it'll go on to the native soil and it'll actually plug everything off. Okay. So a septic mound is built on top of the surface. We don't dig it down into the ground. We apply the sand on top of the grass that you've got there. We scarify it a little bit with the bucket of the equipment, okay, just to kind of mix it up a little bit, but not a lot, right? We don't want to disturb the ground too much. Then on top of the sand, this has got to be at minimum of 12 inches thick if you've got a septic tank, okay? So 12 inches thick of sand. It's really important that we have the right amount for that. If this was a sewage treatment plant, you could go with a thinner sand layer, but typically we're looking at the 1 foot, okay? This one is end fed. You can see the piping coming up this way. That's one method of doing it. Another method is to center feed. So you'd come up on this side of it and into this mound. We don't come up through the sand layer because we don't want to have a path back down into the trench, because the trench is going to be 6 to 8 feet deep typically. And that just gives us an opportunity to have untreated effluent. So over top the sand layer, we may or may not have some washed gravel. Piping is laid out on top of that sand layer, over top of that gravel if you're putting it there. And what that does is it sprays the effluent all inside of here. Now it can be gravel over top, or more typically, you've got chambers over this, okay? Chambers cover all that. Then we've got geotextile fabric, and then we've got topsoil that goes over top, the whole works, and then we seed that to grass, okay? Again, this is built right up on top of the surface. It's all imported material. You're not typically going to be doing a whole bunch with that, with material that you have on site. Again, if you don't use the proper sand, we are going to have a mound that fails. Now, septic mound can be costing anywhere from $20,000 to $50,000 to have built. And if we don't use the proper sand, when it plugs the soil interface down here, that sewage is going to come sideways and your mound is now garbage. It's not something that you can repair. Okay, so we have to make really sure that we're using the right stuff. Here's a really old picture, but we've got a septic tank. This one's 2-piece tank. So we've got our pumping chamber, and then it's pushed out from there into this mound, and then it's spread out. And you can see we've got our topsoil, we've got our sand, geotextile, that sort of thing. What you don't see on here is each one of these laterals that's inside this mound is going to have inspection ports here, 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 and then over on this side as well. That way we're able to look inside and see how the effluent is being applied to the sand. We've also got monitoring ports that we can see down to the sand as well as down to the soil interface. Those caps, they can have sprinkler box caps and that sort of thing over top of them, landscape box caps, or it could even be just piping sticking out of the ground that's just got a friction fit cap on it. Just if you've got that, be aware that if you hit that with a mower, you will destroy those. So here's a picture of a mound that the association built as part of a mound day. So Alberta Onsite Wastewater Management Association does all the training for the contractors. They're sitting in a classroom for 8 days in order to learn how to design and build these systems. And then we also have field days. So they might be going out and seeing how a mound is built, or seeing how a field is built, or an at-grade, that sort of thing. Typically would have about 20 students out there providing the labor to build these systems. Now you can see that we've got our topsoil material here on the sides of the mound. This one, we do have washed gravel over top of the sand layer, and you can see this one curves. The reason for the curve is there's a little bit of a slope here, and when we're putting a mound onto a slope, we have to follow the contour. We can't come, straight out off to the side like this, because we're going to have a mound that's going to fail. All the sewage would find its way down through the easiest path. We've got piping sitting up. It's above the gravel, 4 inches. And you can see the water squirting up here and here and basically all the way along it. This is the stage that, as an inspector, I want to see the installation of a septic mound, because I can come in, I can grab a sample of the sand and ensure that we've got clean washed concrete sand, and I can see that we've got a proper squirt test. So when we design a mound, typically we're designing it for this water to spray up 5 feet. When we look at it during a squirt test, we're able to verify that all of these orifices that have been drilled in here, that this effluent's pushing out from, that we have even flow. We don't want to see 5 feet on this side and see a foot down on this side, because it's not balanced properly, because all that'll happen is the vast majority of your sewage would be applied here, and your mound is going to fail because we're not utilizing the entire thing. So you see the chambers are just off to the side here. After the squirt test, the chambers were put over top of the piping. So 2 rows of chambers, one over this one over this one, and then geotextile fabric over the top, and then we put the soil on top of that. This is an example of an LFH at grade. A lot of places, if you've got a lot of trees and you want to save all the trees, an at grade is a wonderful option. So if you're looking at a mound, you can see how much space that mound is taking. And you saw the picture of the field, you can see how much space that takes. That's all cleared land. Okay, so if you've got a bunch of open land, then that's definitely an option to put either one of those systems in. If you want to maintain the trees, you can put in an at grade. Now, the way an at grade works is you do have to have a sewage treatment plant or an advanced treatment unit. We cannot put regular strength sewage effluent from a septic tank into these. So you can see what happens is it gets put right on top of the forest floor. Okay, now this needs to be in an established forest that has a leaf litter or an LFH layer on the floor. So when you're looking at that, you can see at the top, you can identify as leaves and twigs, and as you start going down through the LFH, it looks like they've been breaking down, and then it basically turns into soil. Underneath here, you can see just poking out here, we've got piping suspended inside these chambers. Okay, the piping's suspended inside there. The chambers snake through the trees. We do not take down the trees. Okay, we snake around through them. We want the trees to be there. We want the LFH layer to be here. Okay, the chambers get put down over top of this pipe that's suspended from the chambers, or it's on pipe stands above the forest floor. Okay, pipe stands like that. Then we cover it all with bark mulch. Okay, now this can't just be sawdust, can't be like planer chippings and stuff like that. It has to be bark mulch. We have to be able to see wood grain in it. It goes over top so that when it settles, we've got at least 9 inches of thickness. So you can see we've got the chamber, we've got geotextile fabric over top of that, and you can see we've got a clean out here. So if anything was to plug into there, this could be opened up and you could actually jet that out. Now you see we didn't disturb the forest floor at all. This one is a little bit older and it's growing back. You can see that we're getting plants coming into here. A LFH at grade will blend in with the forest floor over the years. At some point, you'd have trouble identifying where it is in there, because as the leaves fall every fall, as the grasses and everything else grow in there, it is going to be hiding it. Now, if you've got an at-grade or you're going to be putting an at-grade in, I've got a recommendation. It's not code, it's not a requirement, but it's a best practice, okay? If we've got forests, we've got animals. If you get a big old moose walking through here and he steps on these chambers, he's very likely to put his foot through it and it's going to upset him to no end. And he's going to do a lot of damage to your at-grade. So what you do is you just get some deadfall, and I'm not talking, 8-inch diameter trees and stuff like that, but you get a bunch of deadfall and you throw it over top of where your mulch is, and it makes almost like a little fence. That way the animals hopefully walk around it rather than through it. Again, it's not a code requirement, it's just best practice that keeps the animals out of it. So at this point, we're going to take a break. We're running a little bit ahead of schedule, which I'm sure nobody minds. So we're going to take a break for about 10 minutes, and then we're going to jump right back into this.
In the meantime, if anybody's got a question, then maybe just unmute yourself.
Rick, I do have a question actually about just going back to what you said about using a septic tank as a holding tank. Were you kind of saying that is not a good idea? Like that is a situation that we might encounter where we install a septic tank and we're going to install a field maybe the next year, or we need to replace the tank, but we run out of season. I just wasn't clear on what you were saying there, if it wasn't a good idea to use a septic tank or as a holding tank, or if it could be done.
Okay, it can be done, and it is done. It's discouraged because if a septic tank is put in to be used as a holding tank, it's really easy to install a pump in there and just start pushing out onto the surface with no regard to what the soils can or cannot accept, and then site sizes and that sort of thing. So I know ASCA and whatnot, they're discouraging the use of that. The other thing to keep in mind is if we're installing a holding tank, there's a minimum size requirement of 1,000 gallons for a single family dwelling. So your septic tank would need to be able to hold at least 1,000 gallons. Now, I always recommend to people that you put in a larger holding tank than what the minimum standard is, because typically your sewage haulers, they can haul, depending on the truck they're bringing in, they might, on average, they're hauling 5,000 gallons in that truck, and they will charge you the same to haul 1,000 gallons as it would 5,000. So if you put in a septic tank and you're using that as a holding tank, you might be getting that sucked out every 3 to 4 days. Whereas if you put a larger holding tank in there, you can get it, a month, for instance, before you have to get that thing sucked out. Right. So if somebody's got the minimum size septic tank that they need for their home, if they're only getting 3 or 4 days out of there, then they're a lot more likely to throw that pump from PV Mart into there and just push it out onto the surface to save that, $200 to $300 every week, basically.
Okay, I see where you're going. Yeah, what you're getting at.
Yeah. So it can be done, but sewage hauling it gets really expensive. A septic holding tank is the cheapest system to put in for day one, but over, say, 20 years, it's the most expensive sewage system you can have because you're paying somebody to haul that away constantly.
Hi, it's Ken. Can you hear me here?
Yeah, I got you, Ken.
Okay. I understand that you're not to have livestock, cows in particular, grazing the septic field. I guess the logic would be that you don't want to lose the loft in your soil profile.
Correct.
That is correct.
Yep.
So I've got I guess, a certain level of success of just bringing in a group of cattle for about 5 days, harvesting everything off, and then they're gone for the rest of the time, as opposed to cattle just staying there for the summer. Do you see that as being an issue or acceptable or a little more tolerable in that you got a lot of grass growing there, and the other alternative is to use a lawnmower, and there's a lot of labor to that?
Yeah, so having the animals on there, of course, you're looking at quite a bit of PSI, just based on small hooves and a lot of weight to that animal. So they are going to impact that soil. They're going to compress it. If it's winter time, they might start pushing frost down into your septic field and doing a little bit of damage that way. I would never recommend having any large animals on there. I mean, if you've got goats, yeah, okay, maybe you'll get a little bit luckier that way. But any sort of septic system, whether it's going to be a field or a mound, we prefer that you mow those with a lawnmower with turf tires. You don't take the old Massey Ferguson and drive that back and forth with the bushwhacker behind it, right? We need to preserve that soil structure as much as we're able to. If you compact it too much, then there's a good chance that the oxygen's not going to be able to get down through the soil properly, and you're reducing the life expectancy of your field.
Okay, so the basic bottom line is to keep the loft in the soil profile. Okay, another question I have then as well is that when the septic sucker guys come and put all of that stuff on the back of the truck, is there an environmental issue of them going out to my back 40 pasture and spreading that from one end to the other and letting it fly and utilizing that as a nutrient supply for my pasture?
They would need to have permission from Alberta Environment to do that. So there is a land spreading license that the haulers are able to get. And we'll talk a little bit about that later on, but basically they get permission to apply that effluent, and they can apply it only every 3 years to each portion of ground. And there's some very specific requirements about the type of soil and then what they have to do after they spread it and that sort of thing. So if you've got somebody that does have permission from Environment Canada, they would have to register that portion of your land as being utilized for land spreading.
Okay. But it's because of toxicity buildup, you suppose, or
yeah, because the amount of sewage that's going to go onto there, it needs to be effectively treated. Now, being on the surface, you get UV treatment just as much as you do with evaporation and that sort of thing. Right. They don't want too much going on there so that you have too high of a nutrient load in any one spot. It smells really bad, so neighbors have a tendency to get upset with it. And the part of the reason for the land spreading license and the registering of where all this stuff goes is on occasion health will come out and environment will come with them, and they will walk through that field that sewage has been applied to, looking for things that should have been picked up after the spreading.
Okay. Okay, thanks.
Yeah, no worries.
I just bought a property last year, and the previous owner said it was pumped out the year before, so like 2 years now. Yeah. What am I looking at to spend to have it pumped out, do you think? Because it's probably every 3 or 4 years, I'd imagine.
Yeah, it all depends on the use. I mean, if you're abusing the tank, putting a lot of antibacterial stuff in there and whatnot, you might have to go more often than every 3 or 4 years. If you're really careful and you have a well-established system, you can go longer. As far as cost for getting that sucked out, it varies all over the province, but factor $200-300 to get that thing emptied out. Now, something to keep in mind, and we do talk about this later on, is you don't want to empty your tank in the winter time. We want to try to leave that for the warmer months, just because we're taking all that beneficial bacteria out of there, and then it has to regenerate basically in order to start working again, and you'll lose a lot of the heat that you've got in that tank, and you could end up freezing things off.
Okay, thanks.
Yeah.
Hey, it's Ken again. Got another question.
Yeah.
My field is a little too low relative to the topography around. And when we get the 3 and 4 day rains here that just pour on and on, my whole field just becomes a sog and gets waterlogged. Can I come along in there with another 12 inches of peat or something to spread over top of that to get a little bit more height so as to keep the water away? Or what sort of material would be best to have on that surface there to reduce the incidence of waterlogging?
Yeah,
of flooding?
Yeah, are we talking about the whole area is low, or it's
Yeah.
low from settling on the trenches?
Well, both actually.
Okay, because if it's low from settling on the trenches, then you can use some topsoil in there to level everything off.
Yeah.
Depending on the depth of your trench, of course, we've got a maximum depth of 3 feet. If you've got shallower trenches, you could look at bringing some topsoil in to raise the level up and just seed it to grass afterwards.
Okay.
But you don't want to be any deeper than 3 feet.
The bottom of the trench must be less than 3 feet.
The bottom of the trench, 3 feet or less, you bet, from the surface.
Okay.
Right. Typically, we try to avoid putting septic fields in low areas on properties, especially if you get a lot of rain and whatnot, and it gets waterlogged.
Yeah.
I would question if the system should have been installed there in the first place.
Okay, but it is. So I guess just add some topsoil, get some height to it, so long as it's not more than 3 feet down.
Yeah.
And the best way to test for that is how do I just get a spade and start digging? And
yeah, if you can identify where that field is, then you can dig down to it, and you'll be able to see how deep your trenches are. Just move cautiously. You don't want to mix a bunch of silt and clay into there. Okay. Because anytime that we start digging into a septic system, then there's a potential for doing a little bit of damage to it. Maybe we have, if we've got a system that's getting close to failure, you give a preferential pathway for the effluent to come out, and can create a failure there. But as long as you're digging basically on the end of one of the laterals, and you just dig down to it, then you should be fine.
Okay.
All right. If we don't have any more questions, jump back into it here. All right. I'm assuming everybody can see my slide again. We're into regulations. So like anything else in life, we've got regulations when, we're affecting other people or the environment or safety, that sort of thing. So we do have regulations that are involved in all of this that tells us what we can and cannot do. So the Alberta Private Sewage System Standard of Practice 2015 is the code book that we use for private sewage. So currently that is the one that's in force. In November of next year, we've got a new standard of practice that was just released that will come into effect. It's the Alberta Private Sewage System Standard of Practice 2021. Now, if you Google the Alberta Private Sewage System Standard of Practice, you can actually download the 2021 version now, and you can get that for free. Now, the 2015 version had the standard of practice, or the code, and then it had a standalone book called the handbook. The new code version has the handbook and the standard of practice all in one package. You don't have to pay anything for it. Alberta has decided that anytime we're going to have codes, they're going to make them free to everybody. That way, everybody's able to see what the regulations are so that they can meet the regulations. There's no point in having rules and then not having people be able to get easy access to that so that they can be compliant as they go. So that's the Alberta Private Sewage System Standard of Practice 2021. If you're going to be designing a system or anything like that, or you're just really curious, that is available. The Alberta Private Sewage Regulation is a little piece of law that basically says that the Alberta Private Sewage Standard of Practice is the code book that we use, and it says that all private sewage installations must meet the requirements of the standard of practice. Then we have the Alberta Permit Regulation. The Alberta Permit Regulation is what tells us that we need a permit to do this work. Okay, so if you're going to be building a house, You have to have a building permit for the house. You have to have a plumbing permit, a gas permit, an electrical permit, and then for us rural people, a private sewage permit as well. Okay. Now the permit comes into play if you're building a brand new system, if you are altering your system. So say you've got an open discharge and you want to move the discharge location somewhere else because you're going to be subdividing and that sort of thing. You need to have a permit in place in order to be able to do that. Even as much as just replacing your septic tank, that requires a permit. Okay. That way a safety codes officer such as myself is able to look at what's the plan that you have. Does it meet the requirements of the standard of practice or the code? If it does, we can issue you that permit. Then we can come out and do an inspection just to make sure that everything is done correctly, that the proper materials have been used, it's gone to where the plan said it was going to be, and that sort of thing. So permit regulation governs that. It says you will have a permit for X. Then we've got the Safety Codes Act. The Safety Codes Act governs all of this. The Safety Codes Act lays out what the responsibilities are of everybody in the safety codes system. So it gives the safety codes officers the powers. It gives the Alberta Safety Codes Authority their powers. It lays out that the permit regulation is in force, that the private sewage regulation is in force. It explains what everybody's role is, what they are allowed to do, what they're not allowed to do. It lays out on stuff like orders. So if you've got an issue on your site, say you do an installation and you don't get a permit, a safety codes officer is sent out there by the municipality and says, well, hey, you know what, you've got this septic system, it's not done correctly, you never had a permit, et cetera, et cetera. They might write an order. So SEOs try to work with you first to get compliance. We don't want to go straight to an order, but if we can't work with you and get things done in a reasonable amount of time, maybe an order is written, and the order is basically a firmer way of saying, no, like, you got to do this. You don't have a choice. This is what we have to do to meet the requirements. If an order is not followed, then there's potential for hearings and Court of Queen's Bench and fines and all that other fun sort of stuff. That's all laid out by the Safety Codes Act. So Safety Codes Act governs everything that I do. But then we've also got the Public Health Act. So this is your health officers. So if you've got a sewage problem, say you're pumping your sewage into the municipal ditch, well, that's mine. Okay, that's where the Safety Codes Act comes in. That's where the municipality is involved. That's when we start, looking at the orders, et cetera, et cetera. If the property is a rental property, or if you're impacting water supplies, that sort of thing, that's when health is going to get involved. So with orders, an order, if it's written, usually gives you a timeline of about 30 days to comply with the order. If you don't comply with the order, then it's up to the municipality if they want to take it to court in order to get fines levied, that sort of thing. The Alberta Public Health Act, the health officers, when they come out, they've got ticket books. They can start writing you really expensive tickets right away. And I might come out and tell you, hey, you know what, you got to pull the pump out of that tank. I'm going to give you a couple of weeks to get that done. Health comes out, you're pulling that pump out of the tank before they leave. Okay, so quite a bit of regulations involved with all this sort of stuff, but without the regulations, we would have a lot more problems with water supplies. Algae blooms would probably be that much worse in a lot of our lakes. Rivers and streams would be polluted quite a bit more. So all these regulations kind of help with that. It's no longer acceptable just to go and bury a VW bus behind the house and dump the sewage into there just to make it disappear, or dump it down an old well, that sort of thing. So the regulations set out quite a bit of information, like the standard of practice. It sets out minimum tank sizes for your septic tank, minimum horizontal setback distances from site constraints. So site constraints would be looking at lakes, rivers, and streams, marshes, wetlands, property lines where your well might be, staying away from buildings on your site, and by buildings, I mean occupied buildings. So if you have a workshop that you work in, we have to stay away from that. But if it's just a machine shed where you're storing your combine, there is no setback from that. It also sets your minimum vertical separations from restricting soils or water table. So the picture I showed you towards the beginning where we saw the water table there, and I was talking about that distance from the bottom of the field to that water, that's our vertical separation, okay? Restricting soils might be a heavy clay. It could be bedrock, anything like that that stops the effluent from going down. So with primary treated effluent, so the stuff coming out of a septic tank, we typically need 5 feet to signs of a water table or from restricting soils. Whereas with the secondary treated effluent coming out of a packaged sewage treatment plant or the bottom of that 1 foot sand for the mound, we need 3 feet to a water table or restricting soils. Now, what we're able to do is say you've got a water table at 1.5 feet below the surface, you can still put a septic mound on there. But what you need to do is you need to thicken that sand layer so that you've got the 1 foot of sand minimum, and then you add more sand to get that 3 feet in between the two of them, okay? Keep in mind, if you do have a site like that, it is possible to put that mound on there, but that washed concrete sand is the most expensive part of that mound, so it does increase the price quite a bit. The standard practice also sets the allowable soil loading rates. So depending on the type of soil that you have, there's a chart in the standard practice that lays out how many gallons per day per square foot that soil can take. So depending on the soil, it makes a real big difference on the size of your septic field, for instance, or your septic mound, or whatever the case might be. For instance, if you have clay and you've got primary treated effluent, so the effluent coming out of your septic tank, you can only put 0.14 gallons per square foot per day if it's clay and it's blocky, okay? If you have a sewage treatment plant, you can go as much as 0.2 gallons per square foot per day. But if you've got loam, a blocky grade 2, you can do 0.45 gallons per day from a septic tank or 0.63 gallons per day from a sewage treatment plant. So you can see that there's a really big difference between the two of them. It's not a big difference as far as 1 square foot, but it could make the difference between having, say, a 2,000 square foot field down to a 1,000 square foot field, for instance. Okay, it can make the difference between having, a really huge mound to something a little bit smaller and save you some money. So the soils are the absolute most important part of the entire system. So we get into design and installation now. I'm not going to train you on how to design systems. You're not going to be competent to, do the designs and install and everything else based on this presentation. We're giving you a, kind of a 30,000 foot view on this, just to give you an idea of the different steps that you have to go through, the requirements that if you're going to pull the permit yourself that you have to meet, or if you're hiring a contractor to do the work, the reason why they come out and they ask you 1,000,001 questions and they're digging around on your site and that sort of thing. This will give you a little bit better understanding of all that. So as far as design and installation, who can provide these services? Because the association made all these slides, we're definitely going to tell you that trained and certified installers holding a current certificate of competency from Alberta Municipal Affairs, they can provide these services for the design and or installation, okay? In Alberta, as long as it's a property that you intend to reside in, you can pull the permit, you can do the design yourself. If this is a rental property, you need to hire an installer, somebody that's got a certificate of competency. The permit regulations demand it, Okay. If you're going to live in the place yourself, you can go ahead and design it. If you're not, you need to get a certified designer. So what are the steps? Well, first step is a detailed site and soil evaluation. So you go out onto your site, you have a look, and you say, okay, I'm thinking maybe I want to put in a septic field. I'm going to have a look and see if this is going to accept that or not. So you look around the site and you try to determine where do you want to put this field. We don't want to have the field downslope if we can avoid it. Okay, we don't want to put it into a really low area. Now, a lot of people really like to have walkout basements. They put the house on the top of the hill and they put their sewage system down at the bottom of it. Definitely, I understand why people want to do that, but it's not necessarily the best as far as sewer systems are concerned. If you're going to develop a new piece of land, look at where you're going to put the house and then find at least 2 places where you might put the septic system. Because if one spot's no good, you have another one that you can deal with. During construction, flag off the area that you're planning on putting your septic system so that nobody drives the cat over it and removes all the dirt. Nobody's piling material on it. They're not driving their equipment over top of it, destroying that soil. Definitely, put a couple of spots aside that nobody can touch. Okay. Once you've determined where you want to put this system, now you have to dig test pits. So if this is an open discharge where you're just going to pump out onto the surface, it only requires 1 test pit. All the other systems require at least 2 test pits. Okay. Now, we don't dig the test pit exactly where we plan on putting our system. We don't dig a test pit right in the middle where the field is going to be. We try to bookend that field location as much as we're able to. Keep within about 20, 30 feet of where we're going to put the system. We don't want to be too far away because soils do change across sites on occasion. If it's a septic field where we've got 3-foot deep trenches, we need to dig a 9-foot deep test pit. If it's a septic open discharge, we need to dig a 6-foot hole. If it is an at-grade, we need to dig a 4-foot hole. Because what we're doing is we're identifying the treatment zone below where we're applying the effluent. So with a mound, we need 3 feet below that mound. With an at-grade, we need 3 feet below it. With a open discharge, we need to have 5 feet below the surface. With a field with 3-foot deep trenches, we need to be down at least 8 feet. Plus, we have to identify 1 more foot below that. So that's where we get the 9 feet for a field, 6 feet for an open discharge, and then 4 feet for the at-grade and the mound. Once we have that test pit open, now these are excavated pits. Okay, so you're usually bringing in a piece of equipment to do that. This is not a borehole. You can't just drill down in the ground, pull it out, because you need to actually be able to get into these test pits and identify the soils that are in place and how it's put together. And you got to fill out a document that is more difficult to get right than most mortgage documents, soil profile log form. You have to identify the different layers in the soil, the type of soil that you've got. You need to identify the color, the makeup of it, like what's the shape of the soil, how strong is it, if you have any glaying or mottling, any coarse fragments or a bunch of gravels, all this sort of stuff. There's a lot of information that's required. Now, the glaying and the mottling, glaying, think of washed out areas where the color has been washed out of there, light grays, whites, that sort of thing in the soil. And then mottles are almost like rusty areas, okay? Glaying and mottling are indicative of a high water table, a seasonal high water table typically. So every year the water table comes up high enough where it's washing the color out of the soils. It's causing some rusting in the soils, any irons that we've got, creating your mottles. And then the water, of course, recedes. Those signs, that's what we're watching for seasonal high water table. You cannot have those in the treatment zone. So if it is a open discharge, we can't have any glaying or mottling within 5 feet of the surface. If we're within 5 feet of the surface, you're looking at doing a different type of system, perhaps a mound. Worst case scenario, you're doing just a holding tank. Once you've identified the different layers in the soil on the soil profile log form, you have to take a large Ziploc freezer bag full of soil from the layer that's the most limiting in your test pit. Now, with homeowners, I suggest they take a bag full from every different horizon, because to identify the most limiting is very difficult for the layperson. You send that off to a testing lab, and they send back the results for the texture, and they're going to tell you if you have, like, say, silt or a silt loam, clay, heavy clay, coarse sand, that sort of thing. Any of the soils that do have a sand name to them, you do need to do what's called a particle size analysis to see what type of sand, if it's a fine sand or medium sand, coarse sand, that sort of thing. Because all of that makes a difference on how much sewage can go on each square foot based on the charts in the standard of practice. And that is what you have to base your design on. So you do a full design, and that was just, your soil evaluation. You have to do site diagrams showing where everything's at, your setback distances, that sort of thing. You figure out what septic tank you need. You figure out how big of a system it's going to be. So when we're designing our systems, we're designing it on the number of bedrooms. It doesn't matter how many bathrooms you've got per se. Basically, it is 1.5 people per bedroom, 75 gallons a day per person, okay, just to be sizing your system. There are variables if you've got big jetted tubs and that sort of thing, okay, so all that makes a difference. If you are doing wine making in your house and stuff like that, you actually have to have a bigger system. As well, we need to know if you have a garburator, because if you've got a garburator, both your tank and your field have to be substantially larger to handle all that. So once that design is all completed, it gets sent in to either municipality or an agency where a safety codes officer will review the design that's submitted. If appropriate, they will issue a permit to give permission to do the install. If you do not meet the requirements of the standard of practice with your application, if something's missing, the SEO will ask you for further information, working towards getting that permit out to you, okay? Step number 4, licensed contractor or you as a homeowner can install that system once you have the permit. You can't do anything other than your test pits prior to the permit being issued, okay? If you make the mistake of installing your system before you get the permit, you might find out that the system that you've installed cannot be installed on your site because of site conditions, soils, lot size, whatever the case might be, okay? Don't do the install until you have that permit in hand. Step 5 is the safety codes officer is going to come out and inspect the system. If it's a mound, I'd prefer to get out there during the squirt test just to see everything that's on the inside of it, because if we come out there later on, everything's covered in snow, there's not really a value to you as the homeowner to say, yeah, you know what, the system meets the requirements of the code, because I'm just looking at snow, and I want to be able to give you some value for that. And then the final is the homeowner takes the system over, okay? And if you install it yourself, it's all yours. If you had a contractor install it, as soon as they start using it, you take care, custody, and control of the thing, okay, of the septic system. So movement of water and soil. So water that infiltrates into the soil will eventually either make its way to groundwater or a surface water body, or even both. We have to treat that effluent before it reaches that natural body of water, okay? We don't want to have untreated effluent getting into the water table. Typically the water tables, when the sewage effluent gets into there, it stays in what they call a narrow plume. It doesn't just dilute, it actually follows the movement of the water in the soil, and eventually it's going to come back out, whether it's a water body, surface water body, or maybe it's a few miles down the road and it's your neighbor pulling that up into his house, and he's got, partially treated effluent in the water that they're using to mix formula for their baby, or whatever the case might be, okay? We got to make sure it's properly treated. This isn't disposal where it's just, flush it and forget it, but we're protecting everybody by doing it properly. And quite frankly, if it gets into the water table, it might even be coming up through your own well again. Okay. For treatment of effluent to occur in the soil, it must travel through a required distance of soil in an unsaturated flow condition. We have the 5 feet for primary treated effluent, 3 feet for secondary treated effluent. As long as that soil never becomes saturated, we get good treatment. So we did have a discussion during the break about a septic field in a low spot that gets completely saturated every year. When that system is saturated, we are not treating that effluent. It is raw sewage for all intents and purposes down there. And if that water is the water table that has come up, then we've got untreated effluent in the water table, finding its way to other places. If it is just saturation because the ground is not capable of taking that much water all at once, it will eventually reach equilibrium and it will correct itself eventually, but it will take time and you'll have big stinky mess down there for the in-between time. So we get into using your septic system. So we've learned what a septic system is. We've got some ideas about how to find it. We've got, very broad strokes view of the regulations involved and how we design the system and everything else. For the vast majority of participants, this is the meat and potatoes that you're looking for. Okay, how do we use this septic system? What can I do with it? What can I put into it? What shouldn't I put into it? What kind of things are going on with this thing? So using your septic system, start up in normal use. Okay, so additives, starters, and feeders are not required. There's a lot of old school people that say, well, you got a brand new septic system, throw a dead chicken into your septic tank. That way it starts the bacteria working and gives you a better shot of having a good system. There's different additives that you can add in there. One of them is called Septobac. Seems every time I turn around, somebody's come out with the new best thing. Just dump this in your tank once a week, once a month, that sort of thing, to keep everything flowing properly. I can tell you that these are not required. Okay, septic tanks, their design goes all the way back to the Roman times. Okay, they didn't have the starters and the feeders and all that other stuff back then. These systems, if they're maintained properly, they work without adding any of this stuff. Adding additional bacteria into your tank is actually harmful in that the bacteria that you've got in there currently tries to fight off the new bacteria that's in there because they want to do all the eating and they don't want to have to compete with any of that. So you can actually affect your sludge and scum layers a little bit with that. So we don't need any of that stuff in there. Okay. Using septic safe cleaners. So if you need to have everything like super sanitary all the time, you're breaking out the Lysol and spraying absolutely everything in it. You're putting the blue pucks into your toilets. You are bleaching everything constantly. You're doing a lot of damage to your septic system. We need to have the bacteria in the tank to do its job. If we use too many cleaners, then we're killing off that bacteria. Your sludge and your scum layers are going to grow that much more, that much quicker, and you're going to get suck trucks out a lot more often in order to clean those out. Worst case, you block off and plug off your septic system, and then you've got sewage coming into your house. Okay, so use the safer cleaners, bleaches and harsh cleaners. We use them in moderation. I mean, I'm not saying keep a filthy house or anything like that, but be cognizant that everything that you're putting in there will have an effect on your septic system. Okay. No chemical drain cleaners like Drano and stuff like that. Don't use them. Okay. First of all, it will eat away the concrete in your septic tank. If it makes its way to the concrete, it's going to kill off your bacteria really effectively. And they don't usually work. I've got a plumbing background, been plumbing for a long time. If you do use Drano or caustic or anything like that you're going to be putting into your system, When it doesn't work and you call the plumber out to come out there and snake it, please be very clear with the plumber that you put this stuff down into the drain. Nothing sucks more than getting a chemical burn because the homeowner didn't tell you he put this stuff down there, okay? They don't typically work. And then of course, we're not putting solvents or flammables down there. If you're cleaning paint brushes and stuff like that, none of that goes down into your septic system, okay? We don't put any of that stuff in there. Basically, all that should be going into your septic system is whatever comes out of your body, as well as wash water, you know, washing machines, that sort of thing. Water conservation. So water conservation is important, obviously, but it's not critical on a septic system, okay? Septic systems are a great water recycler, all right? We take water out of the ground, typically, if we've got the wells. I mean, if it's a cistern, okay, definitely you want to be a lot more cognizant about how much water you're using because you're trucking it out there, putting it into your cistern, then you're putting it through your wastewater stream, okay? If you've got a well where you're bringing groundwater up and you've got a septic system where we're applying the effluent back to the soil, we are recycling. Now, you do lose a little bit to evaporation. You do lose a little bit if, you know, you take a cup of coffee off to work in the morning, that sort of thing, right? But we're recycling that water. And if we've installed our systems and maintained them correctly, we're doing a really good job with that. If we use too little water, we actually end up with a higher strength of wastewater, okay? So there's a misunderstanding with some people that they say, okay, well, I want to put a smaller septic system in because I've got, you know, I don't want to spend all this money on this septic system. So they decide, okay, you know, I'm going to put low flow fixtures everywhere. I'm going to put ultra low flow toilets. I'm going to put low flow shower heads, the whole 9 yards, okay? Low flow toilets, typically people have to flush those 2 or 3 times to make things go down, depending on the use of said toilet. The low flow shower heads, most people get rid of those fairly quickly because you just will have to run around in the shower to get wet with those, okay? But what we're doing is we have less dilution of the sewage when it's going out into the tank. So we have a higher strength effluent that's out there. We do not get any credits as far as field or mound sizing based on low flow because now we've got a higher strength effluent that we're treating. Okay, so you don't have to go with the ultra low flow for any of that. At the same time though, using too much water can overload your system. We need to size the system based on the use. So we don't have our water softener regen going into the septic systems. We don't put our iron filter regen into the septic systems. We don't put our groundwater sumps into the sewage system, okay? All that water you would need to adjust for, okay? You'd have to have quite a bit bigger tank, you'd have to have a bigger field, all that sort of thing. And then using too much water in there, all this cold water actually affects the bacteria as well, okay? It's much more beneficial if you've got, say, a water softener to have that regen go into a French drain, you know, off to the side of the house, away from where your septic system is, and just let the water go into the ground there. One thing to keep in mind is most of the people that install water softeners, for instance, they don't always set those water softeners up correctly. So water softeners, when they come out of the factory, they're set to default to the worst, hardest water that they can possibly treat. Okay, so they use the most salt or potassium that they have to in order to be able to treat that water. Get a water sample pre-treatment, find out how hard your water really is, and then get your installation instructions for that water softener and set it up correctly. You'll go through a lot less salt or potassium, you're going to regen less, you're going to use a lot less water and that sort of thing, okay? But try to avoid adding too much water to your system because it will dilute everything and cause you some issues. So again, discharge, backwash, water softeners, high efficiency furnaces, iron filters, RO units, etc., should be diverted away from a septic system. Now, high efficiency furnaces, you'll know if you have a high efficiency furnace because it has plastic venting coming off of the unit, and it either goes up through your roof or comes through the wall at the side of the house. High efficiency furnaces condense, meaning that they take so much of the heat out of the burning of the natural gas or propane that moisture is actually formed in the waste stream, and then it filters down through the furnace and goes to a floor drain, or it goes to a pump that it pumps it over to another drain someplace. Okay. Those high efficiency furnaces in the wintertime can produce up to about 5 gallons of fluid per day. Okay. Now that fluid is really acidic. Okay. It will not affect your septic system if your septic system is in use. Okay. If you're a snowbird and you're leaving for the winter, if the only thing that's going into your septic system is the water from your high efficiency furnace, you are going to have trouble. Okay. It will keep going into your septic tank until such time as your septic tank discharges. If it's an open discharge, it just adds to the skating rink that you've got out there. If you got a field or a mound, you are going to have a frozen field or mound. It might do a lot of damage to it because there is no bacteria in there. As well, if you've got a concrete septic tank and this fluid from your furnace is going into there and it hasn't been neutralized, it will eat a hole through your tank and it'll destroy your tank. There is condensate neutralizing tanks that you can get. They've got limestone chips in there and it goes into there, and when it comes out, it's been neutralized and away you go. If you are gone during the winter all the time, find another spot to pump your furnace condensate to. Don't put it in your septic system because it will destroy it on you. Okay. If your water softener and everything else is already tied into your septic system, try to minimize what you're doing with it and dial those things in properly. As long as you're using it all winter, your sludge and scum and whatnot, they will develop at a faster rate because of the additional cold water you put in there. But you know, a lot of these softener installers, they just put it wherever. So some practical tips. So as far as solid waste goes, we don't put anything plastic or inorganic down our drains. Flushable wipes, condoms, feminine hygiene products, paper towel, etc., that has no place going into your septic tank. Okay. Wipes manufacturers make all kinds of money by saying that they're flushable, and they truly are flushable. You can use that flushable wipe, you put it in the toilet, you hit that button or that lever, it will flush, it will disappear. The problem is it gets down to your septic tank, now it becomes part of your sludge and scum layers. They eventually break down. Okay, there's none that are truly septic safe. They eventually break down, but they break down into a bunch of little fibers. Those little fibers, if they get through your filter, which they are smaller than the filter openings, they get out to your septic field or your septic mound and they start blocking the pores out there. Eventually, over a few years, you will actually destroy your septic system because of these flushable wipes. If you're currently using them, stop. If you've got little kids and they're using wipes to ensure cleanliness, get them to put them in the garbage can. As unpleasant as that can be, if they're putting them into your septic system, you're going to have trouble. Okay. Condoms, all kinds of jokes around those. If you are putting them into your septic system, if they make their way to your pump, they will plug your pump, and somebody is going to be pulling that pump out and pulling these things out of it. Feminine hygiene products, that is the the tampons, that sort of thing. That goes with the applicators as well. Okay, none of that stuff can go into your septic system. Have a garbage can with a lid next to it. Okay, paper towel doesn't break down nearly as fast as one would think. We definitely don't want to be flushing any of that either. Another thing to keep in mind is any soaps that have microbeads. Now, soaps with microbeads are outlawed in Canada. Okay, you cannot buy soaps with microbeads in Canada anymore, except for the dollar store, because for some reason dollar stores are able to bring stuff into Canada and nobody kind of sees what they got going on. Okay, the microbeads are little beads of plastic. they do not break down. They will make their way through your filter and they will clog off your soils. They will destroy your mound or your field, you know, in a few years. It's not immediate or anything like that. Some of them use walnut shell that will eventually break down. Some of them use like pumice, volcanic rock and that sort of stuff. That's going to add to your sludge layer. And at some point, you're paying somebody to haul that away for you. Consider composting rather than a garburator. If you use a garburator, your septic tank needs to be 50% larger to handle all that chewed up food product that you're putting into there in order to be able to handle that additional load. As well, your field needs to be 40% larger. So you start looking, you might go from a field that's 1,000 square feet to 1,400 square feet for the convenience of a garburator, okay? If you have a garburator right now, I would say that your system probably was never designed for it. Please stop using it. If you intend to put a garburator in your house, let your installer know or factor that into your design when you're designing your own septic system. Typically, the same person that would inspect your septic system is the same guy that's inspecting the plumbing system in this new house. So if I come into your house and I'm doing a plumbing inspection, I see that you've got a garburator when I look under that sink. First thing I'm going to do is check your private sewage permit to find out if you accounted for it or not, okay? If you didn't account for it, you're going to fail your plumbing inspection and will reopen your private sewage permit if need be and fail that one as well because of that, okay? If you don't design for it, please don't add it. As well, when you're putting in the big jacuzzi tubs, most people out on the farms, out on the acreages, they only use them once or twice because it takes a long time to fill them. It takes a lot of water to fill them, but your septic system has to be designed as if you use that thing every day. Okay, so consider not putting them in. You're not going to get as much use as you think you will out of it. Try to keep grease, coffee grounds, animal fats, and other solid wastes from going down the drain. Yeah, we don't want to be dumping bacon fat down there. Coffee grounds will not break down in your septic tank. You will be paying to get those hauled out. Your fats and solids going down there, that's going to add to your fats, oil, and grease on your fog layer or your scum layer, as well as your sludge layers, okay? Human waste and toilet paper are safe to put down there, absolutely. With the toilet paper, you don't need to buy the RV or the septic safe toilet papers that you get that, you unroll some of it, you can just about see through it. You don't need to go to that extent. But on the flip side of that, you don't want to go with the 5-ply pillowy soft Bear approved toilet paper either, because that takes a lot longer to dissolve in that tank and to be broken down, and that definitely adds to the work that septic tank has to use. So be reasonable with what you put down there. I mean, at the end of the day, you do you, but everything that you do with that tank needs to have some thought to it. Chemical wise, we don't pour paints, solvents, silicone products, or any construction waste down the drains. When you're having your house built, the drywallers love to use the sinks to clean their stuff, and you get a bunch of mud down the drains. That's going to end up in your tank. The painters want to wash their brushes and everything else in your sink. Anything and everything can get dumped into your system during construction. What you want to do is you want to make sure that your builder or yourself or somebody is basically putting something over top of these drains so nobody uses it, okay? Because anything that they're going to put down into there is going to have an effect on that system during construction. But even, when you're doing maintenance around the house and everything else later on, just don't put anything down in there that's not sewage, okay? Petrochemicals, fuels, oils do not go into septic tanks. I don't see too many people dumping gas into their septic tanks because, really that stuff's expensive and that would just be silly. But Varsol and stuff like that, maybe you're old school and you're washing your hands with Varsol. You don't want that going down to the septic tank. None of that stuff. Garage drains and perimeter drains. So perimeter drains would be your weeping tile, okay? We want to divert that stuff away from septic systems. Your garage drain, if it's a little bit of snow melt going into it, if that's going in your septic system, okay, it's not going to do a lot of damage to it. It might have some effect depending on how much salt is going in there with it. If you're setting it up to be able to wash your cars and everything else in there, definitely direct that drain somewhere else. We don't want all that additional cold soapy water going in your septic system. Your weeping tile, never shove that into your septic system because that's a lot of additional water going in there. As well, we don't want to discharge water towards our septic system. So if your field is downhill a little bit from your house, we want to divert surface water away. We want to divert storm water away. Your downspout shouldn't point there. And you definitely don't want to have your weeping tile discharge pushing water that way because you're going to just end up with saturation. So maintaining your septic system. I'd love to be able to tell you that you don't have to do any maintenance whatsoever to them, that you put it in once, you just walk away and you never look at it. There are people, of course, that do that. I look in a lot of septic tanks in any given month for various reasons. And if you don't maintain your system, you're going to cause a lot of problems in your system. I've seen it where the sludge and scum layers were basically plugged off the first compartment of that septic tank. And it's just a really narrow channel that everything goes through to the pump chamber, and then they're pumping it out onto the surface, and it's just one big stinky mess, and they're backing up into their house and that sort of thing. So maintenance is exceedingly important, whether you do it yourself or you get a sucker or hauler to come out there and do it. So why would you maintain it? Well, you want to save money. Absolutely. I mean, if you put in a septic mound and paid, say, let's call it $30,000 to put that thing in, you want to maintain it, because if you're not maintaining it, that mound might fail after the first year. It might fail after 3 or 4 years. Now you're having to put in another mound in another location. That's why we want at least 2 locations possible on each site. And you're spending another $30,000 to basically rebuild the thing. Okay. If it was a design problem, then maybe it costs you more because it was built too small to begin with. We want to protect the property value. And if you've got a well-maintained septic system, there's no problems with it, you go to sell the property, that's a plus. If you don't maintain it and your septic system's in failure and you go to sell the property and somebody identifies that, well, now you are reducing the sale price to the point where they can put in their own septic system. Okay, so think you're selling your house for $300,000. Now you got to give them $30,000 out of that to put in a new septic mound. Okay, gets expensive quick. And of course, protecting health and environment. Right, it's nothing's dirtier than having raw sewage out on the surface. Helps, the environment will thank you for not doing that. But as well, if you've got little kids, that's where they're going to be playing. If you've got dogs, that's what they're going to be rolling around in, and they're going to want to come up and, get you to scratch them and that sort of thing. Okay, so we want to make sure that everything's maintained. So safety first. Okay, when we're maintaining our septic systems, never, ever, 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 ever go inside your septic tank. Please don't do it. Okay, I've got, I believe I still have the slide for what gases are in there. People die in septic tanks all the time. Okay. They are poisonous environment. They are not friendly to people being in there. If you do, for some reason, have to go into your septic tank, there's only a couple ways to do it safely. The first one is you do it under supplied air, whether it's a Scott pack or it's a SCADA pack, whatever the case might be. You've got supplied air to a mask on your face. You have a harness on, you're attached to a davit. There's a person manning the davit. And then you got a third person that's standing off to the side that if things go really haywire, they're able to call 911. Nobody should be coming into the tank to save you if you go down in there. The other way to do it is to do enough air changes inside that tank and prove the oxygen levels are to a point where you can survive and the noxious and poisonous gases are all gone. Okay. If you go into a tank and you haven't done either of those steps, you are very real on taking your life into your own hands. Okay. Even laying on the surface and sticking your head into that tank can knock you down. Okay, don't do it. Keep the tank lid secure. So depending on the type of tank lid you've got, there's different ways of keeping it secure. If it's concrete, it should weigh at least 65 pounds. Okay. If it's plastic or fiberglass, there'll be screws with it. Some of them will screw into place. They're threaded somewhat, and then you screw them down. Others you just screw in through the sides to get that there. Okay. Make sure your lid is secure. If your lid's missing or it's broken, replace it, please. Kids have a habit of ending up in septic tanks. Okay. If you've got that bale out in the yard and you've got the piece of plywood over top of it and there's no lid under it, please change that. Okay. Somebody walking across your lawn might lift that bale up to see what's under there and fall in. All right. I gave the Septic Sense in person down in southern Alberta 3 years ago, maybe even 4 years ago now. Gave it in a small little town. Did it in the community hall that they had there. Gave the presentation, talked about all of this, and about a month later, somebody had a sewer company out. They had pulled the tank lid, emptied the contents of that tank. They put the lid back on, but they didn't put it on securely. And I believe it was a 3 or 4 year old child went missing a little while after that. They searched for that kid and eventually found the child in the septic tank, and unfortunately, it was a body recovery. Okay, so keep the lid secure. They do kill people. Prevent shock and explosion. We don't have electric connections inside the tanks. You can't do a wiring connection in there. You can't have a duplex receptacle in there where things are plugging in. Okay, we can't do any of that. It is an explosive environment. When something shorts out in there, it will explode. Okay, we don't do any connections in there. As well, you don't put a trouble light in there to kind of keep things warm during the winter. Okay, if you got one in there, when we're done tonight, please take it out, because they do eventually corrode due to the environment that they're in. They do short, and if you just happen to have the right mixture, it will explode. Keeping flammables out of the system, obviously, and we stay out of our septic tanks because there are infectious diseases possible in there, whether it's your tank or somebody else's tank or whatever the case might be. So in your septic tank, these are different gases that can be in there. So we've got hydrogen sulfide, H2S, sour gas, stink damp if you're from the East Coast and in the mines, a bunch of different names for it. Okay, it is explosive. It does have an odor of, like, it smells like rotten eggs, which if you're sticking your head in your septic tank, differentiating the H2S from everything else in there would be nearly impossible. It is heavier than air, meaning that it will sit into low spots. However, it can also rise up when it's attached to steam. If the air moves around in there, it can be displaced that way, so you can still get H2S up to the surface. It is deadly poison, okay? And at high enough concentrations, you can't even smell it anymore because it kills all the nerve cells in your nose where you can't smell it anymore. Methane gas, think natural gas. If you've got gas piped to your house, that's methane. Okay, methane is created from decomposition, so it's definitely going to be in your tank. It is explosive. There is no odor. It's lighter than air. It will asphyxiate you if it doesn't explode. And of course, carbon monoxide, carbon dioxide, and nitrogen can also be present in there. So again, don't go into your septic tanks unless you've mitigated the hazard, because too many people die from that stuff. So inspecting your system. Now, this isn't a me inspection where I'm coming out to have a look during the installation, or if you're doing subdivision, I'm going to come out there and have a look. This inspection is done by an industry professional, or you can do it yourself. Okay, industry professional, typically your different haulers might do that inspection for you. Talk to the septic hauling companies. Some of them, they just send a guy out with the hose. He drops the hose in the tank. He takes everything out and he just walks away. Others will actually come out there and they will check and assess your system and do any tweaking or any upgrades or stuff like that that you need. So you want somebody to have a look at it. They say every year for a regular system. Okay, now a regular system would be something where you've got, a septic tank, and then you've got a mound, or you've got, a field, or whatever the case might be. This could be just simple as have a quick look at it, see what kind of shape it is. If it's a mound or a field, go out there, pull the inspection caps off, run the pump, see how that's all working, that sort of thing. They can judge how much sludge and scum are in the tank, determine does it need to be sucked out or can we wait? All right, if you got a packaged treatment plant, they do require more servicing every 6 to 12 months. You definitely want to be on top of a packaged treatment plant with the maintenance, only because you've got the different filters that are in there, different controls. There's more bells and whistles, more things that could go wrong with it, okay? But that being said, if you're doing the maintenance, you're checking the amperage draws, you're checking the controls and all that other sort of stuff, you're maintaining your system and it's going to get a lot of years use out of it. And again, not all pumpers perform the inspections and do the maintenance, okay? Talk to your pumper before they come out. If one guy's willing to do a full inspection and he's $50 a pump more than the other guy, well, maybe it's worthwhile getting the one that does the inspection, okay? They can save you a whole heck of a lot of money, all right? Even as much as pulling the filter out or pulling your pump screen out and washing those out to remove everything that you've been filtering out of your septic system so that you don't plug off your mound or your field, okay? That maintenance is important. So sludge and scum disposal. So here we've got a suck truck, okay? That suck truck can come out to your house and they will empty the contents of your tank. Now, if you got a holding tank, they're going to come out every single time your holding tank gets full. And if you got a septic tank, they're going to come out, when you need to get your sludge and your scum removed, or if you've got a blockage or whatever the case might be. A couple things to keep in mind with a suck truck. If they come out to your house, stay away from this area. Okay, this is the vacuum portion. So all that moist, smelly air is blowing out from right around here. That's coming out of the side of the truck, and then they got their suck hose on the other side. It's not a bad idea to be out there when they are emptying your tank, especially if you've got a concrete tank, because if it sounds like they're sucking gravel out of your tank, that's usually the aggregate of the tank, and it's an indication that you need to start saving up to replace that tank at some point. Okay, the tank will be coming apart. You can also have problems with, the fiberglass and the plastic tanks as well. If they get a hole in it, you might get some gravel and whatnot coming in. So if you hear a bunch of clanking and bangs and stuff like that when they're emptying, look in to see what's happening with your tank. Now, these guys are really regulated, okay? When they remove the contents of your septic tank, they have very few options of what they can do with it. They can take it to a approved lagoon. So some guys actually have their own lagoon on their own quarter section that they've got permission from Environment and Health to have, and they dump everything into their own lagoon. There's others, you have to go to a municipal lagoon if you have permission, okay? They can't just haul to any lagoon. They need permission to do it. A lot of them are fenced with key cards and everything else now to ensure that. They can take it to a sewage treatment plant. So, they could take it to a gold bar type plant or whatever and dispose of it there. Some of them do have a land spreading license. What the land spreading license allows them to do is they can go out to each portion of land that they have approval for from Environment, and they can apply effluent onto that land once per 3 years, okay? The 3 years is to allow the soils to basically recover from having all this high strength sewage being dumped on it. Now, they need permission to do that from the landowner. They need to have a permit from Alberta Environment. Then they're able to spread onto the land, and they have to do soil tests before they do it, just to ensure that they don't have a lot of sand on there where it's going to be untreated. The idea is that you get evaporation and then you get UV disinfection of that sewage on the surface. Now, when these guys do spray this sewage all over the surface of the land, after the truck is empty, they are then expected to park the truck, get out and walk through the field they just sprayed everything onto and pick up anything that's inorganic, anything that didn't belong in the wastewater stream. So condoms, feminine hygiene products, any of that stuff, anything that is obviously not sewage, they're expected to pick that up and then take that to a landfill to be disposed of properly. If they do not, and environment goes out to that site and they walk through and they start seeing all this stuff when they're walking through with their hazmat suits on, these guys are going to get a massive fine. They'll lose their land spreading license. They will no longer be able to do it. Okay. The regulations are really strict as far as that's concerned. Okay. The other thing to keep in mind is if you're driving down the road and it's dark out, like it's getting dark at 3:30 in the afternoon now, if it's dark out and you see one of these trucks and there's a big stink and this tank is sitting up in the air a little bit and they're parked on the side of the road, get this information off of here and phone environment, because it costs a lot of money to dump in the lagoons and into the sewage treatment plants and whatnot. And there are some haulers out there that they'll charge you to empty your tank and then they'll just find the most convenient place to dispose of that sewage. So tank pumping, right? Getting the suck truck out to empty that tank. We want to do it in the spring and summer where possible. Okay. We want to try to avoid pumping it in the coldest winter months, especially for mounds, fields, any type of system like that. No need to scrub or disinfect your tank, and a professional pumper will assess the scum and sludge layers and plan an effective pumping schedule with you. Now, the reason why we look at the spring and the summer is when we take all this sewage out of there, we're also removing all that beneficial bacteria. We're removing everything that creates heat in that tank. If it's winter time, it's really cold out, we remove all that heat, you could actually start freezing up the inside of your tank. So we want to avoid that whenever possible. Now, if your tank has to be sucked out because it's all plugged up and everything else, okay, there's not much we can do about it, okay? Otherwise, spring and summer. Now, the guys that know what they're doing, they're not going to fully empty your tank. They're going to leave a couple of inches in the bottom of that tank. Now, it's not because they're, ripping you off or they're trying to, be able to come out there more often or anything like that. What that couple of inches in the bottom is doing is it's preserving some of the bacteria that's already in the tank. And it gives you a better head start when you start using that tank again later that day. The bacteria has that jump start on it, and it'll actually keep your sludge and scum layers from forming for quite some time. Okay. We don't scrub out or disinfect the tanks unless somebody's going to be going in there to work. Then, of course, we want to get it cleaned up. And then as far as the pumper assessing the scum and sludge layers, the levels, the rule of thumb is every 3 to 4 years you get your tank sucked out. If you're not maintaining your system properly, if you're using a lot of cleaners and that sort of stuff, you might need to get it sucked out more often. If you're really cognizant of what you're putting in there, you're really careful with it, maybe you can go a lot longer than 3 or 4 years. A pumper that knows his things, he can come out there and use what they call a sludge judge. He can drop that down in your tank, he can pull that out, and he can tell how thick your sludge layer is, how thick your scum layer is. They can look down in the tank and tell a lot of that as well. And he'll be able to give you an idea, well, you know what, maybe we go 4 years, maybe we go 2 years, whatever the case might be. We pump the tanks out when the scum and sludge require it. So this is typically if the scum layer, so that's on the top of the sewage, right, is rising up into your manway, or it's nearing the crossover. And the crossover is where it goes from the first side of the tank to the second side. So if the sludge is getting that high, or the scum is up into your manway, that's definitely time to suck that tank out, okay? When the tank is sucked out, it's a good time for visual inspection of the tank itself. So we can look down, we can see the baffle wall. If it's a concrete tank, maybe that wall is starting to break down due to the gases and everything else that we've got in there. We can look at the lids, the risers, etc. Now, if you're looking down in a concrete tank and you see that baffle is eroded quite a bit, there are some people that will say, oh, we can fix that. We'll form it up. We'll add a little bit more concrete and away you go. But if that baffle is corroded from being in contact with the gases in that tank, what's the shape of the roof of that tank? If the baffle's eroded quite a bit, that roof's in really bad shape as well. Septic tank isn't something that you can repair like that. If the baffle's toast, you got to replace that tank. Okay. The lids, risers, etc. If you got broken concrete lid, good time to fix that. Your risers, if you've got multiple parts to the risers, they need to be sealed. That's a good time to look down and see if maybe the seals are failing and letting groundwater in. If you got groundwater coming into your septic system, you're treating that, you're pumping that, you're having to deal with all that extra water. And then check with your pumper, see if they clean the filters and do other maintenance, do they charge more for it, that sort of thing. You do have to pull out your filters if you got filters or your pump screen, whatever, and you got to wash those out. You should be doing that once a year. If you are pulling them out and doing it yourself, when you do rinse it off with the garden hose, do that overside the primary or the larger side of that tank, so that all the stuff that you filtered out of the pump chamber gets a chance to get retreated. Okay. Really messy job, kind of gross. If you're comfortable doing it, give her. If not, get your pumper to do it for you. So treatment field and mound maintenance. We want to avoid soil compaction. Okay. We don't want to have a field or a mound someplace where we're going to be storing livestock. We don't want to have trucks driving over top of it. Nothing like that. Okay. We want to stay off these systems. We do want to maintain a good vegetation cover. Okay. So we're going to have grass over top of this stuff. We mow the grass. You don't want to just leave it going long because that actually traps moisture. You mow that grass, but again, you don't take the old Massey Ferguson with a drag behind mower on that. This is something that you're taking like a lawn tractor with turf tires or a push mower in order to get that grass knocked down. Okay, anything bigger than that, you're going to run into trouble, and that's year round. Okay, if you got a septic mound, you don't want to be jumping your snowmobile over top of it and that sort of thing. Okay, we just keep everything away from them as much as possible. We want to keep surface waters diverted away from the lids and soil-based components, right? If we add a bunch of water to the soil, we got to deal with that additional water in the soil. If we get saturated conditions, now we got a big stinking mess until the saturation goes away. Also, we plant trees a safe distance away. We don't want to have trees in our fields. We don't want to have them in our mounds, because what happens is the tree roots, they're looking for the best source of nutrients around. Your septic system is beautiful for trees. But what will happen is the trees will actually fill up your septic system with roots, and it's going to plug up, and you're going to end up with sewage in your house very likely, or you're going to have sewage surfacing, that sort of thing. So we keep the trees away. The only exception to that is with the LFH at grade. If you remember, that's the one where we've got the chambers snaking through the trees. Because we're suspending the pipe 4 inches above the forest floor, the tree roots can't get into there. You get all kinds of tree roots below it, but they don't go through the air to plug the holes, to plug the piping and that sort of thing. You want to keep maintenance logs, okay? Keeping track of the maintenance that's done on your septic system helps in a few different ways. It'll tell you when's the last time you had a suck truck out, because we don't get them out all the time. So, was it 2 years ago, 3, 4? You'd be able to look up what it was. Your maintenance log can even have, we have a XYZ half horse pump that pumps out so many gallons per minute, so many head of pressure, right? All that information goes into your maintenance log. When the pump was changed, all that sort of stuff. And where that comes in really handy, especially, is when you go to sell the property, you're able to show, here's the maintenance logs for the septic system. We've kept track of it. Here's everything that we've done with it. And that definitely helps give the prospective buyers a little bit of comfort knowing that they're not buying a system that needs to be replaced right away. So you keep your maintenance records, that way you've always got them. So practical tips for record keeping, definitely practice good record keeping. Make records of what services were done, pumping, filter cleaning, alarm testing, that sort of thing. Who did the work? You know, were you happy with what they did? Know where your system drawings are in case issues arise or work's performed anywhere near the system. And some pumpers or maintainers will have a scheduling system to remind you of upcoming service. When you get the permit for your system, keep a copy of that permit. Keep a copy of all the documentation for that. Keep the system drawings handy, everything else, because if somebody needs to find aspects of your system sometime in the future, these drawings are what they're going to rely on in order to find that, okay? If you're getting a septic system installed for you, the installer actually needs to provide a maintenance package, a as-built drawing, tips on how to maintain your system and all that sort of stuff. They are required by code to supply that. However, a lot of times they might not. So if you've had a system installed, definitely ask for the operations manual for your system so you know what you need to do for this thing. Protecting your system. We keep all vehicles off your field, off the mound. If you're, say, having a wedding out at your property or whatever the case might be, if your system is anywhere near where vehicles may park, flag it off, okay? We don't want vehicles over top the system. Worst case scenario, somebody parks on your septic field and they get stuck, okay? They destroyed your field, they're stuck, everybody's out there trying to push them out of the mud, and that's really gross. We limit activities or events over top of the system. If you got a septic field where it's the trenches installed in the ground, nice flat grassy area, you know, definitely tempting to put stuff up there. You want to know where that's at because you probably don't want somebody putting a party tent up there and pounding pegs into your septic system. You don't want a bunch of people walking over top of it, that sort of thing. No off-road vehicles or snowmobiles over top of your system. Okay, mounds are an awesome jump, but you do a lot of damage. Keep the livestock off the fields and the mounds. We ensure surface water drains away from them, and make sure that downspouts are not draining towards the lids for the tanks or the fields or whatever, right? We want to divert water away as much as we can. So if you have a septic field or a mound at the bottom of the hill, you know, down from your house, all the water that comes onto your parking pad and onto your house and all your property all diverts down towards that field. Consider installing a berm or a swale uphill from your septic system to divert the water away, okay? You know, if your system's already there, okay, well, it's there, but let's minimize the amount of water that goes on there as much as we possibly can. Now, keeping the livestock off the fields and the mounds, there are times where people do the open discharge, they're pumping out on the surface, and they're putting that into their corral. The problem with doing that is now your livestock, your horses or what have you, they're walking through where this sewage is getting pumped and they're beating the heck out of the ground, and that sewage travels further and further before it's able to get into the soil because the compaction that we're going to get there just keeps that moving. With an open discharge, the sewage needs to be able to enter the ground within 150 feet of where it's applied to the soil. And if it's in the paddock or what have you, you might not be able to maintain that. Vegetation. So we ensure that grass or shallow-rooted vegetation is planted around your septic fields and on your mound and that sort of thing. Okay, we don't want anything that's got deep tap roots. We don't want to put the caraganas around there to hide the system or anything like that because they are going to destroy that system for you. Okay. We maintain the grass, mow it, just make sure we have a proper working system. It has a chance to dry out, then we don't get saturation. We don't irrigate over top a septic field or a mound. We're already adding a lot of water there, so if you're putting a sprinkler system on, consider not applying water there. Trees and shrubs, yeah, we want to keep those, you know, a good distance away. The other thing is we don't put our vegetable garden in our septic field. Okay, it's gross, and there's probably a few people, if I can see everybody's faces, that are kind of looking like, really? People do that, but yes, there's quite a few times, even on a surface discharge, you know, the effluent is running from the surface through their vegetable garden, It makes for really big vegetables, but don't do that, please. So troubleshooting. So now we've gone through and we've learned what a septic system does, what it's supposed to do, how we design a system, installing it. We've touched on, maintaining it and sort of that sort of stuff. Now we're going to talk about troubleshooting. So what kind of problems we could have and ways to mitigate that. So if we got sewage in our building, why do we have sewage in our building? Well, we could have roots clogging the pipes, right? We have a blockage in the line, a damaged sewage line, excess water from leaking fixtures or toilets, pump failure, or freezing. Okay, roots clogging the pipes, roots clogging your soil treatment portion. Yeah, if you've got those caraganas and everything else out there, that's definitely going to cause you some problems. Blockage in the line. If, say, your line from your house to your tank has a belly in the line because it wasn't installed properly to begin with, get a blockage there, that sort of thing. This picture that just popped up right here, this is a distribution box that's clogged by roots. If you recall the slide that I showed where it was the house and it just had the two laterals coming out, that distribution box, which allows the effluent to go to the different laterals. If it's clogged by roots like this one is, nothing's going to go anywhere. The sewage is going to try to come out of the tank. It's going to back up because of that. It might surface right there if you're lucky, but it's probably going to end up in your house. So what are the concerns for sewage being in your building? Well, there's the gases that we have in the tank could be coming into your house, pathogens and viruses, damages your furnace, your water heater, other appliances. Basically, if the sewage gets to any of the gas valves on any gas appliance, it's now garbage. You're looking at cutting out drywall and pulling insulation and everything else for that. Fungus, mold, other organisms, you'd be surprised how fast mold and stuff grows. I went down to High River after the floods as part of the rapid assessment teams. We went into every single building in that town while it was evacuated, and day 3 there was mold growing on the drywall upstairs because of the moisture. And of course it affects electrical wires and gas lines. So if you do go into the building, be cautious going into there. Open windows right away to circulate the air. Of course, we're not going to add any more water to our septic system until we fixed it, right? Pump out the septic tank, drain the sewage. The hauler, when he's out there, if you got a bunch of sewage in your basement, he'll drop that hose through your window if you ask him to. Look to see what the problem was, right? Was it a power issue? Did your pump fail? Right? Wash the floor with disinfectant. Consult a professional if need be to come out there and have a look at things. Okay. A lot of times this might be just as simple as the breaker got tripped. Okay. Maybe your pump started to overamp, tripped the breaker. Maybe somebody shut a breaker off for whatever reason, or they unplugged your pump outside to use the power for an extension cord for a weed whacker, whatever the case might be. Check for the power. Sewage surfacing in the yard. So some causes that could be excess water going into the system. Your field might be blocked. Your field might not have been designed properly to begin with, right? Maybe you had a system that was built for a 3-bedroom house. Now you've developed the basement, added 3 more bedrooms. You've moved a really big family into there, and now your system is just destroyed because of the amount that's going into there. It can also come in because of pump failures, or your field's completely destroyed. Now this picture here, this white creamy looking stuff that's all over the place, that's what sewage effluent looks like when it's up on the surface. Okay. All the white, that's your papers that have been broken down, that's little fibers and that sort of thing that's in there, as well as soaps. Okay. So if you've got sewage effluent in your yard, you're going to know about it. It's going to smell and it's going to be a big mess. Here is a tank that the lid's not secure on, and the tank has actually been overflowing for a little while. You can see the soaps and whatnot coming from here, and then the ground is completely saturated around it. So what are the concerns? Well, the gases, the pathogens, it attracts pests and pets, and it causes contamination of the water and the soil. If you've got dogs and you got sewage surfacing in the yard, that's where your dog is going to go. For whatever reason, they just love to go out there and roll around in it. Okay. What do? You reduce your water use, consult a professional, use a vac truck, restrict access to the area, and make sure it's not flowing onto adjacent property. If sewage is surfacing in your yard, it's basically game over. stop pumping into your septic system, assess it, find out what the problem is, and rectify it. Now, odds are if it's surfacing in your yard, your system is no longer going to be valid. It can't be used anymore. Some people will say, oh no, you know, you add an oxygen, like an air pump to your system and you'll be able to recover it. You add our special mystery bag of stuff into your tank, you'll be able to recover the system, that sort of thing. In 20 years, I haven't seen any of that stuff work yet. Someday somebody might come up with something that will. But right now, if you're surfacing in your yard, you're looking at a whole new system. Sewage odor indoors. Possible causes of that would be a sewage backup into the house. Your roof vent pipe might be frozen closed, a dry plumbing trap, improper plumbing, or sewage surfacing in the yard. Improper plumbing, you would get that during the new construction phase. You're not going to see that in an older house. Your roof vent pipe being frozen closed is really possible during the winter time, not now as it's so warm, but check and clear the roof vent. So have a look from the outside, look up at where your vents are for your plumbing. If it looks like it's frozen off, you want to get that cleared off. Okay, use a roof rake, something to get to it. If you're going to climb up on the roof to do it, please be safe. Your traps. So if you've got an unused trap, say you've got a laundry sink in your laundry room, you never use it. You've got a floor drain that doesn't get a condensate drip to it or anything like that. You've got a shower in the basement that never gets used. Add a little bit of oil, linseed oil, vegetable oil, anything like that. Put about half a cup or so in there after you refill the trap with water. And what that'll do is it'll prevent the water in the trap from evaporating, and it'll keep the sewer gases in the pipes where it belongs. A lot of times, as a plumber, I got called out to places that had sewer smells in the basement, and it was just a random trap. And I put water into it, add a little bit of oil, and charge the hourly rate. Okay, add a little bit of oil to it. If you do dump a bunch of water through it at some point in the future, top up the oil again, that sort of thing. If you still have the odor, consult a plumber, have the pump or septic tank looked at. Sewage odor outdoors could be from sewage in the yard, surfacing. Monitoring ports could be damaged or removed. Your manhole cover, your tank lid might be open or not fastened down. Your system might be inoperable, or it could be a thermal inversion. If your tank lid cover isn't in place, please, you know how I feel about that, get it fixed. Thermal inversion. So we've all seen them when it's really cold outside and all the exhaust that should be going up comes down. Okay, so you see that the exhaust can be a furnace rather than going up. It's coming down and almost like a fog, that sort of thing. If you're outside and you've got that, your sewer gases will do the same thing. Instead of going up and dissipating in the atmosphere, they'll actually come down to the surface and you can get a sewer smell from that. Okay, so if you got a temperature inversion, you smell the sewage, doesn't mean that there's a problem. Sewage odor outdoors can attract pests and pets. Contamination of water and soil is a possibility. Nuisance. Neighbors hate smelling other people's sewage. Open discharges require 300 feet to every property line for newer systems because we're dumping sewage effluent onto the surface and we're trying to avoid that smell bothering the neighbors. Okay. What do we do if we got the odor outdoors? Check caps, replace the lids, consult professional, troubleshoot, figure out what's going on. This tank right here, you can see they just got a few pieces of plywood that are thrown on top of this ultra ribbed riser. Okay. That is not an approved tank lid. This one would have a plastic lid that screws down into place, and then there's about 8 stainless steel screws that go into it. Okay. If you've got something like that, please address it. If your alarm goes off, why is your alarm going off? Well, it could be that your pump is unplugged. Check the plug. Could be the electrical breaker for the pump. The pump is tripped. Check your breaker. Could be that your pump has failed and you need replacement. Your outlet might be plugged or frozen. Okay, if you got an open discharge, maybe that's frozen off. Right? If you've got a septic field or a mound, maybe they're frozen up. Maybe they're plugged up. Okay. Follow the power. All right. Start with the breaker. If the breaker's good, go out to where you probably have a duplex plug outside. Unplug it. Plug in a lamp or something that you know works. If you got power there, fantastic. depending on the system that you got, you might have a piggyback style plug. So one part is for the float for the pump, the other part's for the pump. Pull those two apart, plug the pump in directly, and see if the water level starts to drop in the tank. If it does, that means your float is damaged or it's stuck or whatever the case might be. Okay, if the pump doesn't work, now you know it's a pump problem. Okay, just follow the power. That is the end of the presentation. Okay, like I said, I will stick around to be able to answer questions and that sort of thing for everybody. For more information, you can send an email to Alberta Onsite Wastewater Management Association at info@aowma.com, or you can phone the 877 number, and the ladies there will be able to help you out. If you're looking for a contractor to come do work for you, whether it's the maintenance end or design install, whatever, the association maintains a list of contractors in different areas of the province for different aspects of the systems, and they'll be able to give you the names for 3 or 4 different people that would be able to come out there and help you out and get things all fixed up for you. All right. Alternatively, you can get a hold of the county, and they can put you in touch with me as well. I'm always available to answer questions for people. It's always best to send me an email. I am a fairly busy individual, but like I say, I answer questions for people all the time. I don't need to know who you are, where your property is. I'm not going to, come jumping down your throat or anything when you come to me asking questions about something that's going on with your system. All right, so I'm going to stop the presentation so I can see everything. Does anybody have any questions whatsoever about anything that I've discussed, anything that we didn't touch on, anything that I need to clarify a little bit? No questions at all? We got them all in the break? Fantastic.
Great. If there's not any more questions, we'll wrap things up. Thanks so much, Rick, for the presentation tonight. Lots of great information for everybody, whether you're new to owning septic systems or just learning the maintenance side of things. That's really great. So if there's no more questions, then we'll just wrap things up, and everybody have a great evening.
Thanks, everybody. It was my pleasure.